So welcome, and let's continue. Let's do part 3 of our exam 1 review. And that's question number 6, evaluate the following integrals. So the first integral is the integral of log x base 2 divided by x with respect to x. So we can start by writing this in terms of index notation. If you call this one log x base 2 to be equals to y, this is the same as 2 to the power of y equals to x. And this, if you introduce natural log on both sides, we have natural log of 2y equals to natural log of x. And this, by the properties of natural log, is y natural log of 2 equals to natural log of x. So y, if you divide by natural log of 2, we have natural log of x divided by natural log of 2. So we go back to the integral. We have the integral of natural log of x divided by natural log of 2, that's a numerator, divided by x with respect to x. So 1 over natural log of 2 is a constant, so can be factored out. And then you integrate natural log of x, this divided by x with respect to x. So by quick inspection, you find that we have a function and its derivative in one function. So that means we can use change of variables or use substitution. And we call u to be the function that we can differentiate to get the other one. So we have u equals to ln of x, because we know if we differentiate u with respect to x, we have 1 over x. So meaning that our solution becomes 1 over natural log of 2 integral of u, that's ln of x, then dx, one that I'm putting in an ellipse, it's dx in the numerator and x in the denominator, which is the same as dx times 1 over x, that is du. So and this becomes 1 over natural log of 2 u to the power of 2 when you integrate, divide by the new power, that is 2. Then plus a constant c because it was indefinite integral. Finally, we substitute back our u, which is now 2 times natural log of 2, and then the u becomes natural log of x squared. We can put natural log of x in that form, plus a constant c. That's answer for number 1, Roman 1. For Roman 2, the integral, if we inspect, we have 3, but in the denominator, we can have 4x squared, that's 16x squared, plus 1 with respect to x. And this, if you were to rewrite in the form of 3, then 1 plus 4x squared. And then if we let u to be equals to 4x, then this function will become 3. So with respect to x here, we have 3, and then 1 plus u squared. And if u is 4x, then derivative of u will be equals to 4, equals to 4. Then we multiply by dx on both sides. So if we were to isolate dx, we'll be having du over 4 equals to dx. That means that our dx, it's du divided by 4. I can put a division here, divided by 4. So that means I can factor out 3 divided by 4. Those are just numbers. Then you're integrating a function of u, 1 plus u squared. And this, if we recall what the derivatives of inverse trig function, we will find that this is 1 over a, if we had an a, which is 1, tan inverse of now this one is u over a plus a constant c. So our a is 1 because the integral says 1 over a squared plus x squared is, with respect to x, is the answer 1 over a arctan or tan inverse of x plus a constant c. So in this case, our a is 1. So we have 1 over 1, that is 1. Arctan or tan inverse, let me write arctan u, and our u was 4x plus a constant c. And then let's not forget, we had factored out 3 over 4. So that is the second answer for the second question. Let's go to number 3. And number 3, we have two types of functions. One is exponential function. Another one is trig function. So if we have two different types of function, so what we use is integration by parts. And integration by parts, it's if you were to recall if we have two functions multiplied together, u and v, and then we find their derivative because we want to derive the formula for integration by parts, this is the same as derivative of the first function, fixing the second one, plus derivative of the second function, and then attach the first one. Then if you were to do the integral on all sides with respect to x, because these are functions of x, we have that this part, the integral of a derivative of functions, it's that just the original arrangement of functions. Then here we have the integral of u prime v plus the integral of v prime u. Now, because we are finding the integral, so we can have isolate this one, v prime u, and we have integral, one which is isolated, u v prime is equals to uv minus integral of v u prime. So this is the formula that we will use for this question. And we will recall the acronym LIATE, meaning that trig function will come first. So this will be my u, and exponential will now be my v prime. So my u in this question, which is trigonometric function, is cosine of 5t. And my v prime equals to exponential to the power of 3t. So let's find, because we need in the right-hand side of this formula, we need a u and a v. So we have u, so we need to find u prime, which is minus 5 sine 5t. And we need to have a v, because we need to have all the things we need in this formula. And our v will be the integral. So it's the same function, exponential power 3t, but instead of multiplying by a 3, we multiply by the reciprocal of 3, which is the derivative of the power. So meaning that our integral of exponential power 3t cosine of 5t is equals to u, which is cosine of 5t, v, so start by v, a third exponential power 3t multiplied by cosine of 5t minus integral of v, which is a third exponential to the power of 3t multiplied by u prime, which is minus 5. So I'm having two minuses on the same side, so I can change to plus, times 5 sine 5t with respect to t. I'm missing respect to t, even on this first part here, with respect to t. So this becomes a third. Cleaning it up, exponential power 3t cosine of 5t plus, factor out the constants, 5 over 3 integral of exponential power 3t sine of 5t with respect to t. So now this part here, we need again to integrate until we get to where we started. So we have called our u by this integration by parts again, another integration by parts. Our u is equals to exponential power 3t. No, sorry, sine 5t. Let me cancel that one. Sine 5t. And our v prime, which is exponential part from the acronym exponential power 3t. So this means that u prime equals to 5 cosine of 5t, and our v will be equals to a third, as we did, exponential power 3t. So we have that now the integral, which we started with exponential power 3t, is going to be longer, cosine of 5t with respect to t is equals to this part, which is not changing, a third exponential power 3t cosine of 5t plus 5 over 3, and observe, I use these square brackets. Derive the integral of exponential power 3t sine 5t dt, then I need to write this one, uv. My u for this part, it's sine 5t, and v is a third 3t. So I have a third exponential power 3t with sine 5t minus the integral of the v, which is a third exponential power 3t u prime, which is times 5 cosine of 5t with respect to t. So that is now the second integral. So let's observe that now this answer on the right-hand side becomes a third. So we still have this integral. I'll create more space. Exponential power 3t cosine of 5t with respect to t is equals to a third exponential power 3t cosine of 5t. Now let's open the parenthesis, plus 5 over 9 exponential power 3t sine 5t, then minus, this 5 over 3 is multiplying everything in the square bracket. So 5 over 3 times another 5 over 3, that's 5 squared, that's 25 over 9. Then integral of exponential power 3t cosine of 5t with respect to t. This is the integral sign here. So we observe that if I was to use different colors and maybe create more space for this question, it's this, whatever we started with, the integral of exponential power 3t multiplied by cosine of 5t with respect to t, and these are the same, exponential power 3t cosine of 5t with respect to t. So that's where you stop. If whatever you started with starts to get to repeat itself. So if I call this integral I, because it's the same, and this one I, that means that the answer, let me create more space a bit. So that means if I was to, let me use this color, I'll be having I equals to a third exponential power 3t cosine of 5t plus 5 over 9 exponential power 3t sine 5t minus 25 over 9 I. So if I was to bring i's on one side, I'll be having I plus 25 over 9 I, those added together, equals to a third exponential power 3t cosine of 5t plus 5 over 9 exponential power 3t sine of 5t. So I plus 25 over 9I, it's like 25 over 25, I plus 25 over 9, I, which becomes 50, this divided by 34. I equals to the right-hand side, a third exponential power 3t cosine of 5t plus 5 over 9 exponential power 3t sine of 5t. Then to isolate this integral, which we started with, will be equals to multiplied by the reciprocal of 50 over 34, that's 34 over 50, multiplying everything on the right-hand side. 1 over 3 exponential power 3t cosine of 5t plus 5 over 9 exponential power 3t sine of 5t. That's the answer. We'll do number 4 later. Let's do number 5. Let me call it number 4 for this case. Let me change colors to blue. So the integral of cosine to the power of cosine x cubed, then square root of sine of x. This can be written as cosine x, all this cubed, then sine x, all this to the power of a half with respect to x. And then we can split cosine of x to have 2 copies times 1 copy of cosine. Then sine. That means that we have a function and its derivative in one type of a function. So if we recall that cosine squared of x plus sine squared of x equals to 1, we'll be having that this is, if I was to isolate cosine squared of x, we have 1 minus sine squared of x. And then we write this integral. Cosine squared of x is 1 minus sine squared of x. Then multiply by cosine of x. Then multiply by sine of x to the power of a half with respect to x. And that if you relate u to be sine of x, this will mean that we're integrating 1 minus u squared cosine of x. Sine of x will be u to the power of a half cosine of x, if you do the derivative, you have du equals to cosine of x dx. So that means du. And this now becomes, if we open the parentheses, we have u power half minus u 5/2 with respect to u. So this becomes, when you integrate, u to the power of 3/2 divided by 3/2, the same as 2/3, minus u add 1, you have u 7/2 divided by 7/2, which is like multiplied by 2/7, or as a constant c. So which becomes, now if you replace u with x's, 2/3, our u is sine, so it's sine of x to the power of 3/2 minus 2/7 sine of x to the power of 7/2 as a constant c. So that's part one. That's part three of the exam.